Okay, we're using the unit circle to find cosine, sine, and tangent of various angles. And so we're going to look at the angle 4 pi over 3. We're going to use the symmetry of the unit circle to find sine, cosine, and tangent, given what we know about the well-known angles in the first quadrant. Where is 4 pi over 3? Well, it's a little bit more than a straight angle. Looks like this. Its terminal side is in the third quadrant. And this angle here that the terminal side makes with the negative x-axis has size pi over 3. And I'm going to extend this terminal side to a line passing through the origin, and that gives me a ray joining the origin to the unit circle in the first quadrant. And the angle this ray makes with the positive x-axis is the reflection of this angle pi over 3 in the origin. So this angle here is pi over 3. Now, I already know the sine and cosine of pi over 3. The cosine is 1/2 and the sine is the square root of 3 over 2. And that gives me the coordinates of where this ray cuts the unit circle. Now, this point is the reflection in the point over here where the terminal ray of 4 pi over 3 cuts the unit circle. It's the reflection of that point through the origin. So I can now derive the coordinates of this point. When I reflect a point through the origin, it makes both of the coordinates negative, or it makes them the negative of their previous values. So the coordinates of this point are negative 1/2, negative root 3 over 2, and these are the cosine and sine of this angle 4 pi over 3. So I have cosine 4 pi over 3 is the first coordinate here, which is negative 1/2. Sine 4 pi over 3 is negative root 3 over 2. Tangent 4 pi over 3 is sine over cosine, so it's negative root 3 over 2 over negative 1/2. Those negatives and the 1/2s cancel, and that's the square root of 3. Let's try another angle, minus pi over 3. We want to figure out its sine, cosine, and tangent, and all of these depend on the terminal side of the angle. So we draw a picture of the terminal side of this angle. It's in the fourth quadrant. And I'm going to reflect this terminal side in the positive x-axis to get a ray which is in the first quadrant and makes an angle of pi over 3 with the positive x-axis. And as before, I know the coordinates of this point. That ray cuts the unit circle at the point 1/2 root 3 over 2. And it's the reflection in the positive x-axis of the point that I'm interested in. And what happens when you reflect a point in the positive x-axis? Well, the x value remains the same, but the y value switches to its negative. So the y value here is negative root 3 over 2. And now this gives me sine, cosine, and tangent of the angle negative pi over 3. Cosine negative pi over 3 is the x-coordinate there, it's 1/2. Sine negative pi over 3 is the y-coordinate, that's negative root 3 over 2. And tangent of negative pi over 3 is sine over cosine, which is negative root 3 over 2 all over 1/2, and that's just negative root 3. Let's try another angle. 11 pi over 6. That's almost 2 pi, but not quite. It's pi over 6 radians short of 2 pi. So its terminal side is in the 4th quadrant. And this angle here is pi over 6. Once again, I'm going to reflect that ray in the positive x-axis to get a ray in the 1st quadrant, which makes an angle pi over 6 with the positive x-axis. Now I know the coordinates of the point where that new ray cuts the unit circle. They are cosine pi over 6, which is root 3 over 2, sine pi over 6, which is 1/2. And now the point that I'm interested in, the point where the terminal ray of 11 pi over 6 cuts the unit circle, has coordinates which are the reflection of this point in the positive x-axis. The x value remains the same. The y value changes to a negative. And we're now ready to read off the cosine, sine, and tangent of 11 pi over 6. Cosine is the x-coordinate here, which is root 3 over 2. Sine of 11 pi over 6 is the y-coordinate, which is minus 1/2. And tangent of 11 pi over 6, sine over cosine, which is minus 1/2 over root 3 over 2, which is minus 1 over root 3. And the last angle of interest is 5 pi over 4. So once again, we want to identify where its terminal side is. And this is a little bit larger than a straight angle, and it extends an angle of pi over 4 beyond the straight angle. This angle here is pi over 4, and as I did with one of the angles above, I'm going to extend this line to give me a ray through the origin, or at the origin, from the origin, in the positive, in the 1st quadrant. And the angle that this new ray makes with the positive x-axis is pi over 4. And I know the coordinates of the point where it cuts the unit circle. They're cosine and sine of pi over 4, so they're 1 over root 2, 1 over root 2. And the point that I'm interested in is the reflection of this point in the origin, and that makes both of these coordinates negative when I reflect. And now I can read off cosine 5 pi over 4 is negative 1 over root 2. Sine 5 pi over 4 is negative 1 over root 2. And tangent 5 pi over 4 is negative 1 over root 2 over negative 1 over root 2, so that's 1.